everyone, myself P. Rashika, working as Assistant Professor in SNS College of Pharmacy and Health Sciences in Department of Pharmaceutics. Now we are going to see the topic of surface active agents and HLP scale. Surface active agents. Molecules and ions that are adsorbed at interfaces are termed surface active agents or surfactant. Surfactant have two distinct reagents in their chemical structure, one of which is water linking or hydrophilic and other of which is water hating or hydrophobic. These molecules are referred to as amphiphilic or amphipathic molecules or simply as a surfactant or surface active agents. An alternative expression is amphiphil, which suggests that the molecules or ion has a certain affinity for both polar and non-polar solvents. Reduction of surface and interfacial tension. When surfactants are dissolved in water, they orientate at the surface so that the hydrophobic reagents are removed from the aqueous environment. The reason for the reduction in the surface tension when surfactant molecules adsorb at the water surface is that the surfactant molecules replace some of the water molecules in the surface, and the forces of attraction between surfactant and water molecules are less than these between two water molecules. Hence, the contraction forces is reduced. Surfactant will also adsorb at the interface between two immiscible liquids such as oil and water and will orientate themselves with the hydrophilic group in the water and their hydrophobic group in the oil. The interfacial tension at the interface, which arises because of similar imbalance of attractive forces as at the water surface, will be reduced by this adsorption. Classification of surface active agents. It's depending on their charge characteristics. The surface active molecules may be anionic, cationic or zwitterionic, அதாவது amplophilic or anionic. Anionic agents, the most commonly used anionic surfactant are those containing carboxylate, sulfonate and sulfate ions. Those containing carboxylate ions are known as soaps. Generally are prepared by the sulfonification of naturally fatty acid glycerides like in alkaline solution. The most common cations associated with the soaps are sodium, potassium, ammonium and diethanolamine. The chain length of the fatty acids ranges from 12 to 18. Cationic agents, a number of long chain cations such as amine salts and quaternary ammonium salts often are used as a surface active agents which dissolve in water. However, their use in pharmaceutical preparations is limited to that of antimicrobial preservations rather than the surfactant. The arises because the cations adsorb so readily at the cell membrane structures in a non-specific manner, leading to cell lysis. Example, hemolysis as an anionic to a lesser extent. It is this way that they act to destroy the bacteria and fungi. Amphoteric agents. The major group of molecules falling into the amphoteric category are those containing carboxylate or phosphate groups such as the anion and ammonia or quaternary ammonium groups such as the cation. The former group is represented by various polypeptides, proteins and the alkali pentonides. The latter group consists of natural phospholipids such as the lecithins and cephalins. Non-ionic agents. The major class of components used in pharmaceutical system is the non-ionic surfactant. For their advantages with respect to compatibility, stability and potential toxicity are quite significant. It is convenient to divide these components into those that are relatively water insoluble and those that are quite water soluble. The major types of components making up of the first group are the long chain fatty acids and their water insoluble derivatives. HLP scale. Griffin in 1947 devised as a arbitrary scale of values to serve as a measure of the hydrophilic lipophilic balance, that is HLP of surface active agents. The hydrophil lipophil balance number is measure of the balance between hydrophobic and hydrophilic portions of a surfactant. The HLP number of surface active agent is given using as an arbitrary scale which for non-ionic surfactant ranges from 0 to 20. The HLP value of emulsifier can be determined experimentally or can be compounded as long as structural formula of the surfactant. In general, molecules that are oil soluble have a low HLP value and their volatile substance soluble have a high HLP value. Suffix active agents and their HLB value. In antifoamic agents, the HLB value are 1 to 3. In water and oil emulsifier agents, 3 to 8 is a HLB value. In wetting agents or spreading agent, the HLB value are 7 to 9. Oil and water emulsifier, there is a HLB value of 8 to 16. In detergent, 13 to 16 HLB value. And solubilizing agent, 16 to 18 are the HLB value of the solubilizing agent. Calculations of HLB value. It is for a simple alkyl ether is in the hydrophilic consists only of the ethylene oxide, that is HLB equal to E by 5. E is the weight percentage of ethylene oxide group. In second, polyhydric alcohol fatty acid esters, example glyceryl monostearate, HLB equal to 20 20 minus S by A. S is the saponification number of ester, A is the acid number of fatty acids. Material not having a saponification number, example beeswax and lanolin derivatives. So E plus V divided by 5. P is the weight percentage of polyhydric alcohol group in the molecular, that is glycerol or sorbitol is used as the polyhydric alcohol group. In four group contributions, HLB summation of hydrophilic group number minus summation of lipophilic group numbers plus 7. For a mixture of two surfactant containing fraction fraction F of A and L minus F of B, it is assumed that the HLB is an algebraic mean of the two HLB number. So HLB mixtures F, that is a fraction of HLB A plus 1 minus F HLB B. Thank you.